Hi class, this is Neil, and this is the first video on Lesson 9, which is a review of everything we've done in Unit 8. The purpose of this lesson is to review for our exam. Alright, so first let's just think about the three major formulas we've learned with exponential growth and decay. The first is kind of the standard exponential growth and decay formula, and that's really given by a equals p, or what we start with, times 1 plus or minus the rate as a decimal raised to the power of t. The next formula that we've been looking a lot at in this unit is the compounding interest formula. That formula is given by a equals p times 1 plus or minus r divided by n raised to the power of n times t. N here is the number of compounding times per year. So if we're dealing with something that's quarterly, that n value would be 4. If we're dealing with something that is weekly, it would be 52. Daily, 365. So the n value changes as we change the compounding frequency. Okay, the next formula that we're going to look at, or we have looked at, is when we're dealing with things that compound continuously. So the way that we would write that equation is a equals p times e raised to the power of rt. R again is the rate, t is the time. Note in this equation that the rate appears as the exponent. E is our compounding continuously sort of constant, and that is the number we investigated. That's approximately 2.78. All right, so based on the problems we see, we use different versions of the exponential growth and decay formula. So let's look at one of these in practice. All right, so question 2. If the coronavirus started with 100 cases and it continues to spread with cases with a positive result for the test growing at an exponential rate, various statistics and data currently show the exponential growth rate of COVID-19 is approximately 7.2%. Determine and state a formula C of t that could be used to determine the total number of cases at t days from the initial case. Okay, so we're not told anything about this growth rate compounding at a certain frequency per year. We're not told anything about it compounding continuously. So we're just going to use our regular exponential growth formula here. So I'll just write that again. It's a equals p times 1. Because this is growth, we're going to be adding on the rate and raising it to the power of t. T is the number of days from the initial cases. Okay, so this function has to be in terms of c of t. Our initial number of cases is 100, and that's given to us in the problem. We know our growth rate is 7.2%, so as a decimal, that's 0.072. If I add that to 1, I'll have 1.072. And I'm raising that to the power of t, where t is the time in days. So that's really my exponential formula for this particular situation. Okay, so for part 2 of this question, using your formula, determine how long to the nearest day it would take for there to be 120,450 people that are infected with the virus. All right, so what we're really solving for here is that variable t, which is the time in days. So we know that after a certain amount of time, or we're predicting this number of people will be infected, 120,450. So I replace that with c of t. I'll write the rest of my equation as I wrote it before. All right, so we need to isolate our variable. In this case, it's the exponent. To do that, the first thing I'm going to do is divide both sides by 100. Divide both sides by 100. Okay, that's going to cancel this out on the right side of the equation. On the left side, I'll have 1,204.5. And that's going to equal 1.072 raised to the power of t. Okay, so now remembering back into earlier this unit, to get rid of that base of 1.0272, we need to take the log of that number on both sides. So I take the log of 1.072 on the right side, and I also do that on the left side of the equation. Ooh. Sorry about that. All right, so what that does on the right side of the equation is it cancels everything out but my variable. And I'll just write it now in a different color. So now we have t equals log 1.072 of that number that we started with, 1,204.5. All right, so what we need to do now is actually move to our calculator. And recall that in earlier lessons, we learned to input this in the calculator. I actually need to write log of 1,204.5 and divide that by log of 1.072, and that's equal to t. All right, so I can't do this by hand, so I'm going to actually move to a calculator. I'm going to move to Desmos. And to input this in Desmos, I actually need to type in log. So I'm going to go to the alphabet, type log, go back to my numbers, and then it was the log of 1,204.5. And I'll close the parentheses. And remember, I'm going to be dividing that. Go back to type in log of 1.072. All right, and so what I get there is 102.03. So going back to our notebook, I see that t then equals 102 days. Okay, so take a minute, get those notes down for that problem. Pause the video if you need to. Okay, so the next question and last question to do now is another word problem that we're going to have to interpret. Sorry for the sort of sickness that's part of these do now problems. Just has to do with exponential growth, really. So the flu is spreading exponentially at TVF with an initial population of 10 students. So that's how many students start with the flu. The number of new flu patients can be modeled by using this equation. I of t equals I naught E raised to the power of 0.12 D. And then after that, we're given some definitions where I naught represents the initial population and D represents the number of days that are passed. All right, and then it asks how many days will it take for the number of new flu infections or flu patients to reach 5 times the original size. Okay, so there's really a lot to interpret there. The first thing I'm going to start with, though, is I'm going to go ahead and write my equation that was given to me. I of t equals I naught, and then times e raised to the power of 0.12 d. Okay, so a few things here. I naught is actually given to us. It represents the initial population. And we're told that the initial population there is 10 students. That's given to me in the problem. So I naught represents the initial population. The initial population is 10. All right, so the next piece of that problem. We're really interested in how many days it will take for the number of new flu patients to reach 5 times the original size. So we're interested really in what is the time it takes for our population to reach 5 times what we started with, or 5 times 10, which is 50. Okay, and we are looking for D. We don't know what the time in days is here. All right, so let's input this into our equation then. So I'm going to write 50 for what we end up with equals 10, which is our initial number of patients, times e to the 0.12 d. Okay, and we're going to approach this problem just like we approached the last one. So the first thing I'm going to do is divide both sides by 10. That cancels out the 10 on the right side. On the left side, I'm left with 5 equals e to the power of 0.12 d. Okay, so recall from an earlier lesson that to get rid of that base of e, we actually take what's called the natural log, or ln, of both sides. Okay, that's going to cancel out the natural log, cancel out the e on the right side, so I'm left with 0.12 d equals the natural log of 5. Again, there's no way for me to do this without a calculator, but I'm going to hold off on the calculator for just a second, because let's just isolate d. Let's get d by itself. And so the way I would do that is I would divide both sides by 0.12. That cancels this. And then I have d equals that natural log of 5 divided by 0.12. This is what I'm going to put in my calculator. So let's move over to Desmos to do that. All right, again, I'm going to have to type in ln. And now natural log of 5 divided by 0.12. Okay, and I get 13.4. Let's see what the problem is really asking us to round to. I see 13.41198. Going back to the problem, we're supposed to, well, it doesn't say really. It just says how many days will it take for the number of new flu patients to reach 5 times the original size. Well, let's then just say that it's about 13 days. All right, that's going to be the end of this video, and we'll come back on the next one to take a look at some of the review problems that should help you complete the homework assignment.